some exponent properties. We did this a little bit at the beginning of the year, and you've done it in previous classes as well, so it should be a review for you. Our objectives are to use the product of a power property, use the power of a product property, they're just a little different, and then simplify expressions involving these properties. So first of all, what is an exponent? It's when you have a base number raised to the power of something. So in this one we have the base of a, I'll italicize that, being raised to a power of n. So we're just saying any number raised to another number is equal to the multiplication of that number as many times as your exponent is. So for example, let's do an example here. If you have -3 to the 4th power, that would mean you have -3 times -3 times -3 times -3. So this is the base, the -3, and the exponent is 4, and it tells you how many times, 1, 2, 3, 4, to multiply the base. If it's a negative base, like in this one, then you put parentheses around your base. If it's a positive base, like say you had 4 squared, then you don't need to put the parentheses when you multiply. Also, we don't use a x for multiplication in algebra and beyond, so we use a dot, or you can use the asterisk on your keyboard, or you can use parentheses to show multiplication. So don't use the x anymore for multiplication because it looks like a variable. Here's our rules and properties. The first one is called product of powers. When you multiply like bases, you add the exponents. So for example, let's go to the example. 2 to the 3rd times 2 to the 4th is the same as 2 to the 3 plus 4, which you could write as 2, oh, my keyboard isn't turned on, 2 to the, put my exponent using that key, 7th, and then you can, if you had to write that in, or evaluate that, then that would be 128, because 2 times 2 times 2 times 2 times 2. But you don't always have to write it that way. A lot of times you'll leave it as 2 to the 7th. Okay, the next one is called power of a product. When you raise a product to a power, apply the exponent to each factor. So a and b are factors in this product. And if you have ab being raised to the nth power, then that is the same as a to the nth times b to the nth. And here's an example with variables and numbers. If you have 3x raised to the 4th power, that's the same as 3 to the 4th times x to the 4th. And because we can simplify 3 to the 4th as a number part, then you could write that as 81x to the 4th. That 81 came from 3 times 3 times 3 times 3. And then the last one we'll look at on this worksheet is called power of a power. When you raise a power to a power, you multiply the exponents. So if you have b to the nth power raised to the mth power, then you would multiply the n and the m together. Here's some examples with numbers. 2 to the 3rd raised to the 2nd power is the same as 2 to the 3 times 2, and 3 times 2 is 6, so that's 2 to the 6th, and then if it asks you to evaluate, then it's 64. So if you're asked to leave as an exponent, you would leave it as 2 to the 6th, and in this example at the top, you'd leave it as 2 to the 7th. But they ask you to evaluate, then is when you actually calculate out what the number would be. Here's a little bit of an example problem here that combines some of these rules together. So we have 5a squared times -2a to the 3rd to the 4th power. You need to simplify this part before you deal with the 5a squared part. So you'll see the first thing that I did is I used the power of a product rule. That will be -2 to the 4th power times a to the 3rd to the 4th power. And then I evaluated -2 to the 4th because that is just -2 times -2 times -2 times -2. Didn't we do that somewhere? No. And that would be 16. And then for the a to the third to the fourth, we're going to use the power of a power rule, which says that when you raise a power to a power, multiply the exponent. So that's a to the 12th. And then finally, we're going to put our number parts together. Our coefficients are 5 and 16, so we'll write those next to each other. It's all multiplication. Notice that I'm using this asterisk, the star, instead of a time sign. And then I'll put my variable parts together, a to the second power times a to the 12th power, and then we'll use the product of powers rule that says when you multiply like bases, add the exponents. So a to the second times a to the 12th is a to the 14th, and 5 times 16 is 8. All right, some of these problems, the ones that are highlighted in yellow, are solved in the Khan Academy video that is in your assignment, attached to your assignment. And I'm going to do a few more. And remember, you can look back at the rules and the example at the top of the page whenever you need to. I'm going to do number 3. So the directions say, write in exponential notation. Make sure you always look at the directions. If you want, you can use this sign to show an exponent will follow, or you can use your formatting tools. A superscript will let you write an exponent like you should. All right, so let's do number 3. We have negative 2a times negative 2a times negative 2a times negative 2a. So I have negative 2a in parentheses being repeatedly multiplied. So keep the base in parentheses, and then you just have to write this in exponential form. So there's 1, 2, 3, 4 times that this was being repeatedly multiplied. So you can use that shift 6 key to show an exponent, and you can do then to the 4th power, that means. Or you can click on this button here and then put the 4 as the exponent. And that's all you have to do on that one. Let's look at the next section. It says find each value. That means to evaluate. That means to go ahead and figure out what this would be as one single number. So let's look at number 8. In number 8, we have negative 0.6 being repeatedly multiplied. And notice that it is a negative base. So what I really have is a negative 0.6 times a negative 0.6. And then we need one more of them because our exponent is 3. So I'm going to make sure that I put the base in parentheses before I multiply them together. And a negative times a negative times a negative will be a negative. So my answer will be negative. Then I'm going to get the calculator. You can use the one that's on your computer. And I have to multiply negative 0.6 times negative 0.6 times negative 0.6. Well, my calculator, this calculator, you put the number in first and then the negative. Or you could just multiply 0.6 times 0.6 times 0.6 and know that the answer would be negative. And I get negative 0.216. Do not round this to like 0.2. Put all of the numbers as your answer. And that's the answer for number 8. All right, let's look at number 10. Number 10, we would have, it says 3 squared. So that's 3 times 3. Or you can just know, you can do 3 squared in your head. 3 squared is the same as 3 times 3. That's 9. All right. And then we have 0.2 to the 3rd power. Let's use our calculator to find what is 0.2 to the 3rd power. Now I could do 0.2 times 0.2 times 0.2, but you'll see that there are some options over here for exponents. If it was the 2nd power, I could use this. But I have a power that's not shown on here. X to the y means you can put in whatever exponent you want. So I already put in the 0.2 for the x part, and the y I want a 3. So 0.2 to the 3rd. And see, you can check up here. Is that really what I wanted it to be? That is what I wanted it to be. It was a positive, so I don't have to worry about the parentheses or the negatives. And it's 0.008 or 0.008 if you want the 0 in front. And then I would have to multiply that number times 9 to get my final answer. Calculator still has the 0.008, so I can multiply it in the opposite order. Multiplication is commutative, and I would get 0.072. Okay, so we did a couple of those problems. The next section, it says simplify by writing with exponents. It doesn't say to evaluate or to find the value. So we will not find the final answer here. We'll leave it with exponents. So the answer for 11 and 12 will have an exponent in the answer, and 13. In 14, we wouldn't be able to evaluate anyway because we don't have any numbers. These are just variables. So we're just going to use the rule that says when you can look back, when you multiply like bases, you add the exponents. So it would be x to the something for that one. Let's look at number 16. That one looks a little bit tougher. In number 16, we have 4a squared times negative 3a times negative 5a to the fourth. Well, each variable already has their exponents applied to it. There's, like, we wouldn't put 4 squared because that 2 is not is with just the a. It's not outside the parentheses. And then we have negative 3a and negative 5a squared. So I'm just going to rewrite this with the number parts, the coefficients in front. So we have a 4, we have a negative 3, and we have a negative 5. And then I'm going to put all the variable parts. So I have a squared, I have an a, and I have an a to the fourth. So it helps a lot to organize, to put the coefficients together and the variable parts together. So now I just have to multiply. Let's do these parts together first. Negative 3 times negative 5 would be a positive 15. And then 4 times 15 would be 60. And you can check it on your calculator. 4 times 15 is 60. Yep. And then over here, we're going to use the rule that says when you multiply like bases, add their exponent. But there's no exponent on this one. If you ever have a variable without an exponent showing, you can put a 1 on there. So let's erase that circle and just put a 1 on here. So we have to add 1, 2, 3 plus 4 is 7. So we have a to the 7th. So the answer for this would be 60, a to the 7th. Okay, the last part just says simplify. If it just says simplify, you can leave exponents in your answer. Unless they're simple, like if you had like 2 to the 3rd power, you can go ahead and simplify that. That's simple. But if it's a really big number for an exponent, then don't evaluate it. Just leave it as the exponent if it's a big number. We're not going to write things in the hundreds of thousands here. All right, so let's look at number 19. It says negative 2x y to the 4th z to the 2nd, all raised to the 5th power. What does this mean? This means that every one of those factors has to be raised to the 5th power. So I would have negative 2. Note that I put that in parentheses because the base is negative 2. And then I would have x to the 5th, and then y to the 4th to the 5th, and then finally z to the 2nd power to the 5th. So this is not the answer. We're not done yet. Negative 2 to the 5th, you can leave it like that, but that is not a hard one to, it's not going to be a very big number when we simplify it. I know the answer is negative 32, but I'm going to double check by taking 2 negative, actually, watch this. Let's see if this works. I know the answer should be negative. Does this calculate a negative, or will it? Yeah, it does, but it's saying it's negative because the negative is in front. I really should have put parentheses around the base and then raised it to the 5th power. So negative 32 is correct, okay? And then x to the 5th, that's as simplified as it can get. Y to the 4th to the 5th, the rule is when you raise a power to a power, you multiply the exponent. So that would be y to the 20th. And z to the 2nd to the 5th, same rule, when you raise a power to a power, you multiply. So that would be z to the 10th. Now this is as simple as we can get it. Don't combine anything else past that point. All right, we got time for one more problem. We have number 21. It says 4a to the second times negative 2a to the third to the fourth. This is very similar to the example that is at the top of your worksheet. I don't do anything to the first part. I'm just going to rewrite it as 4a to the second. Just hold that for there now. But the next part, I have to apply the exponent of 4 to each factor. So this would be negative 2 to the fourth, and then I would have a to the third to the fourth. So I can't simplify this at all, so I'm going to move to this part. Negative 2 to the fourth. Let's look at that on a calculator. If I just type in negative 2 to the fourth, it's going to give me, oh, it did it right. Usually, most calculators would give me this as a negative 16. But this calculator is smart enough to know that I really meant negative 2 to the fourth. This should be a positive answer because negative 2 times negative 2 is a positive 4, and then you have that twice, so 4 times 4 is 16. Okay, so this is 16. Watch that on your calculator, though. And then I have to, when I have a power raised to a power, I have to multiply, so I would have a to the 12th. And then I still had the 4a squared here. Now I'm going to rewrite this with the number parts next to each other. Those are called coefficients. 4 times 16, and then I'm going to put all the variable parts together. A to the second, a to the 12th. And we combine by multiplying 4 times 16. That's 64. And then the rule for this is that when you multiply like bases, you add their exponents. So that you can see that you have to keep using those same rules over and over again, and usually use more than one when you simplify. So this was the answer for 21. I used up a lot of space for that. You're always welcome to add, if you printed this worksheet, you're writing by hand, and maybe you find you don't have enough room. So maybe before printing, you add a couple extra lines by hitting enter on the Word document. Then when you go to write your answers, you'll have more room. If you're typing, you can just hit enter whenever you want. And remember that some of these other problems that I didn't do are solved in the Khan Academy videos attached to the assignment. Thank you very much. Have a wonderful day.